What's going on, everyone? This is Gaurav and welcome to my learning channel. So in today's video, we're going to talk about one of the most important concepts in statistics, which is normal distribution. Let's break it down in the next few minutes. Imagine that you measure the height of a large group of people. Most of the people will be somewhere around the average height, while few of them will be extremely tall or extremely short. When you plot this data, it forms a beautiful bell-shaped curve, and that is called a normal distribution. This is how it looks like. So on x-axis of a normal distribution, you will have the variable values. So in our example, it could be feet or inches of a height of person. And on y-axis, you will have the frequency or the probability distribution, which is the number of people or probability with that particular height. Right in the center, you will have the mean of this particular distribution. With this, let's take a look at some of its property. First property for normal distribution is that it's symmetric around its mean. What it means is the area that you have on the right hand side of the mean will be equal to the area that you have on the left hand side of the mean. And also the shape of these two curves, which is right and left hand side of the mean, will always be equal. And because of this property, mean or the expected value of this distribution will be equal to its median and will also be equal to its mode. Now let's try to understand this property with the help of a simple example. So over here, we have a normal distribution with mean equal to 50. This is the center point. And then you also have two more points on this graph. You have 40 and 60. And one thing to note here is that difference between 50 and 40 is 10. And that is also equal to a difference of 60 and 50, which is again equal to 10. As you can see that both of these points are equidistant from its mean. So with that, you have four sections on the graph. You have A, B, C, and D. As I mentioned earlier, that normal distribution is symmetric about its mean. That's why area under the curve for this particular section, which is A, will be equal to area under the curve for this section, which is D. And the way to denote this will be probability of A equal to 0.2 and probability of D equal to 0.2. I have assumed that this particular area is 0.2, which is equal to this particular area. Now let's take a look at another property of normal distribution. So normal distribution takes theoretical value of plus minus infinity, which means that this graph, this particular curve, will never touch the x-axis. It will keep on going. And asymptotically, it's supposed to touch your x-axis at plus infinity or minus infinity. However, for all practical purposes, almost all of the probability, which is 99.7%, lies between plus minus 3 standard deviation. So if you're doing any kind of a hypothesis testing, as long as you are able to measure the overall effectiveness of a particular hypothesis within plus minus 3 standard deviation, that's good enough. That's more than sufficient because that will cover about 99.7% of this entire graph. Another thing to note is how do you denote normal distribution? In order to denote a normal distribution with a mean mu and standard deviation sigma, you would write it something like x is a function of n with a mean mu and standard deviation sigma. So as long as you write this, this is sufficient for you to denote any kind of a normal distribution. And that's a quick crash course on a normal distribution. If you found this helpful, please hit that like button and subscribe. Thank you.